Hello students, Namaskar to everyone. I am Mukesh Sitpal, Assistant Professor, School of Agriculture, ITM University, Gwalior. So today I am going to deliver my lecture on transpose of the matrix and inverse of the matrix. How to find the transpose of matrix and inverse of the matrix. So today we will discuss these topics. Okay. So firstly we will discuss what is transpose of matrix. So suppose we have given a matrix A. So when we do the transpose of the matrix, it will be written as A to the power T, means transpose of A. In some books, the transpose of matrix is also denoted by a term A dash. So that is another kind of presentation of transpose of the matrix. So you may write A dash or A to the power T after the transposing a matrix A. Okay. So what we do in transposing a matrix is we are interchanging the rows and columns. Means columns are converted into rows and rows are converted into columns. After transpose of the matrix, so suppose a matrix A whose order is m into n. After the transpose of the matrix, the order of the matrix AT becomes n into m. It is reversed. Okay. So after the transpose of the matrix, the order of the matrix will be reversed. So here example is given. You have given a matrix A. The order of this matrix is 3 by 2. There are 3 rows, 1, check, 2 and 3. 3 are the row and 2 are the column. This is first column and this is second column. So when we transpose this matrix, this 3 by 2 matrix will be converted into 2 by 3 matrix. So this is the first row. The first row is converted into first column. So this is converted into first column, 2, 3. Second row 1 0 is converted into second column 1 0, and third row is converted into third column 4 5. So like this way we can transpose a matrix. Next, the properties of transpose of the matrix. So when we do the transpose of a matrix who is already transposed, AT is the transpose of matrix A. If we again transpose that matrix, the answer will be your matrix A. Okay. So if we transpose the product of two matrices A and B, A into B transpose, then it is equal to transpose of B into transpose of A. So it is also known as reversal law of transpose of the product of two matrices. It is also known as reversal law of transpose of the product of two matrices. So in this topic we discuss how to transpose a matrix. So now we will study what is inverse of the matrix and how we perform or how we calculate the inverse of a matrix. So suppose you have given two matrices, matrix A and matrix B. Okay. So if we multiply matrix B to matrix A or matrix B to matrix A, if the resultant will be a unit matrix I, then what happened? So I is equal to 1, the determinant of unit matrix is 1. So we can say that AB is equal to 1. Okay. So or we write B is equal to 1 upon A. Okay. So in denominator its power is 1. So when this power comes to the top, the power sign of the power will be changed. So it can be written as A to the power minus 1. So inverse of matrix is represented by a term inverse, its power minus 1. So A to the power minus 1 means inverse of A, that is equal to B. So in this case, if the product of two matrices A and B or B and A is a unit matrix, in that case we say that the matrix B is the inverse of matrix A. In that case, B is called the inverse of matrix A, or it is denoted by A inverse. Okay. So how to find the inverse of matrix? There is a working rule to find the inverse of matrix. Firstly, we have to find the determinant of the matrix. In step 2, if the determinant is a non-zero term, if the answer of the determinant of the matrix is not equal to 0, then only we find the inverse of the matrix. Step number 3, then we have to find the cofactor of each element of the matrix. And after finding the cofactor of each element, we have to form a cofactor matrix. Next, we have to transpose the cofactor matrix. When we transpose the cofactor matrix, then it is called adjoint of the matrix. It is written as ADJ, adjoint of matrix A. Okay. Then to find the A inverse or inverse of the matrix, we have to find the adjoint of A divided by determinant of A. This is the main formula of calculating the inverse of the matrix. So now we will see an example to find the or calculate the inverse of the matrix. So here an example is given. Find the inverse of the matrix. So a matrix is given to you. So we write here A is equal to this matrix that is given to you. First step is to find the determinant of the matrix. The process of determining the determinant is, so you have to select any three number, these three, or these three, or it may be these three, and these three. Okay, so that's depends on you. So we find the three elements 1, 2 and 3, first row. Okay, and we take this element 1. So we write it is equal to 1, that is similar to this one. Okay, and place a bracket. So we have chosen this one. So we have to hide the column in which this 1 is there, and we have to hide the column in which this element is present. What is remain? 2, 3, 4 and 9. So we have to cross multiply it. 2 multiplied by 9, 2 9 ja 18. Then we have to place minus. Then 4 3 ja, that is 12. Then we have to erase this. Okay. Then we have to take this number, second number. So in middle term it is written as we have to write a sign minus. So it is 1, so we have to write 1. Place a bracket. Again hide the column in which this element is present and hide the row. So what is remain? This 1 1 and this is 3 9. So we have to cross multiply it. 1 multiplied by 9, that is 9, minus 1 multiplied to 3, that is 3. Okay, then we write plus. Now the third element, this 1. So we write here 1 and place a bracket. We hide this column and this row. What is remaining? 1 1 and 2 4. So to multiply 1 with the 4, 1 4 is 1, minus 1 into 2, 1 2 is 2. So 18 minus 12, it is 6. 6 multiplied to 1, that is 6. 9 minus 3, that is 6. 6 into minus 1, that is minus 6. 4 minus 2, that is 2. And 2 multiplied this 1, that is plus 2. 6 minus 6, it is 0. And 2 is remaining. So the determinant of A is 2. So that is not equal to 0. Then we have to find the A inverse. Because the determinant is a non-zero term, so A inverse is exist. If the determinant is 0, then A inverse is not exist for that type of matrix. Okay. Now we will go to the third step and we have to find the cofactors of each element. So firstly we have to write the matrix, that is 1 1 1 1 2 3 and 1 1 1 1 2 3 and 1 4 9. 1 4 9. Okay, so this is our given matrix. So here it is given A11, A12, A13. So first letter denotes row and second letter denotes column. So first row and first column. So this is the first row. This is the first row. Okay. First column. This is the first column. So which number comes in bracket? This one. Okay. So cofactor of this one. To find the cofactor C of any element, we have to write minus 1 to the power I plus j into capital M. Capital M is the minor. So what is minor? Minor I will discuss. So we write cofactor of this one. This one is this one. Okay. So minus 1 to the power I plus j. I means number of row and j is the number of column. So here 11 is given to you, first row and first column. So here you have to write 1 plus 1 simply. Okay. Then minor. Minor is after hiding the row and column, what are the elements left? 2, 3, 4, 9. 2, 3, 4, 9. This is the minor. And 2 into 9, that is 18. And 4 into 3, that is 12. So 18 minus 12, that is equal to 6. But minus 1 to the power 1 plus 1, that is equal to the power 2. Okay. So minus 1 into minus 1. So minus and minus, multiplication of minus and minus will be plus. So it is plus 1. If the power is minus 3, so it is minus 1 into minus 1 into minus 1. So product of minus and minus is plus, and plus and minus is minus. So at that time it is comes minus 1. So you have to remember, when the powers becomes odd, and the power becomes odd, there is a negative sign comes in front side. Okay, when the power is even, then we have to write plus sign. The answer reason for that we have explained here. When there is only two terms, then the answer is plus. When there is a 3 minus, the answer will be negative. So here power is 2, minus 1 into minus 1, there is a plus. So plus 1 is not written here, because if you multiply 1 with any number, then there is no change. So here 18 minus 12 is 6. Next, we have to find the cofactor of 1, 2. 1, 2 matlab first row and second column. So this is your second column. So it's talking about this element 1. Okay, so here we write minus 1 to the power, it is 12. So it is 1 plus 2 here. 1 plus 2. So 1 plus 2 is 3. So because 3 is an odd number, so we have to write a minus sign in front side. Then what is left? This 1 1 and this is 3 9. So it is 1 1 3 9. So 1 multiplied with 9, that is 9, and 1 multiplied to 3, that is 3. So 9 minus 3. 9 minus 3 is equal to 6, and 6 multiplied to the minus, that is minus 6. Next, one 3, A1 3, first row, third column. So it is talking about this number 1. So it is written cofactor of 1. Okay. So minus 1 to the power, it is 13. 1 plus 3. 1 plus 3, it is 4. 4 is an even number. Due to that, minus is not coming in front side. So 1 multiplied to the 4, that is 4. And 1 multiplied to the 2, that is 2. 4 minus 2, that is 2. Here what is the number remain? 1 2 1 4, that is written here. So like this way we can find the cofactor of first row. Similarly, we can find the cofactors of second row. Second row means 2 1 means second row first column. Okay, so I will show you a number of third row and second column. That is not okay. So I show you one more number, that is second one first column. Okay, A21. So second row is this row. Okay, second row and first column. So it is second row, this is second row, and first column. First column means this column. So which element it is talking about? This one. Okay, cofactor of 1. So we write minus 1 to the power, there is 21, 2 plus 1. 2 plus 1, that is equal to 3. It is an odd number, due to that it is written as minus. And what are the minus? So minus that is remaining, that is 1 1 in the top side and 4 and 9 at the bottom side. 1 1 4 9. So we have to cross multiply it. 1 multiplied to 9, that is 9, and 4 multiplied to the 1, that is 4. 9 minus 4, that is 5, and 5 multiplied to the minus, that is minus 5. So like this way we can find the cofactors of second row, each element of second row and third element of each row. So these are the cofactors of first row, these are the cofactors of second row, and these are the cofactors of third row. Now in fourth step we have to prepare a cofactor matrix. So in cofactor matrix what we do, so these are the cofactors of first row. Okay, 6 minus 6 and 2. So we arrange that in row 6 minus 6 and 2. The cofactors of second row, that is minus 5, 8 and minus 3. So we have to write these numbers in the second row. Okay. What is minus 5, 8 and minus 3? So minus 5, 8 and minus 3. What are the cofactors of third row? That is 1, minus 2 and 1. 1, minus 2 and 1. So this is the cofactor of the matrix, cofactor matrix. Then we have to find the adjoint of A. So what is the adjoint of A? What is the adjoint of A? We have to transpose the matrix, cofactor matrix. So 6 minus 6 and 2 is in row, then we have to convert it in column. 6 minus 6 and 2. Then second row is minus 5, 8 and minus 3. So that is written in second column. The third row will be converted into third column. 1 minus 2 and 1. 1 minus 2 and 1. So this is called the adjoint of the matrix. And last but not the least, A inverse is equal to adjoint of A divided by determinant of A. So here we write the adjoint of A, this matrix here, and here it is 1 upon determinant of A. So determinant of A is 2. Okay, so we have to write, because this is in denominator, so we write it in denominator. So this is 1 by 2. So we have to multiply this 1 by 2 to each term. Means we have to divide this 2 to the each element. So 6 divided by 2, that is 3. Minus 6 divided by 2, that is minus 3. 2 divided by 2, it is 1. Minus 5 divided by 2, it is minus 5 by 2. 8 divided by 2, that is 4. And minus 3 divided by 2, that is minus 3 by 2. 1 divided by 2, that is 1 by 2. Minus 2 divided by 2, that is minus 1. And 1 divided by 2, that is 1 by 2. So like this way we can find the inverse of the matrix. So I think you are aware about how to find the inverse of the matrix. So thank you so much.